Okay. Let's begin with the permutations, counting and permutations review. This is a net part A topic. On this channel, I'll be doing only part A topics for the time being. Right. So let's say that there are two letters A, B, and you want to arrange them. So how many ways can you arrange them? So it is AB and BA. Okay. Suppose you've got three letters A, B, C, and you want to arrange them. Arrange any two letters. Arrange any two letters. So it'll be AB, BA, AC, CA, BC, and CB. So there are 6 ways of arranging two letters out of 3 letters. Now out here in arrangement, the order is important, meaning AB, BA are not the same thing. They're two different things. Okay. Now let's say you want to select. So that was arrangement. And let's say you want to select. Okay. From 3 letters A, B, C, you want to select 2 letters. Yeah. So now you'll have AB. Yeah. The BA does not matter. AC, CA does not matter. BC, CB doesn't matter. Why? Because in selection, order is not important. Whereas in arrangement, the order is important. So out here, AB and BA are the same thing. So BA, CA, CB, you can cancel them out, and there are only 3 selections. So there are only 3 ways to select 2 letters out of 3. So remember, when you're arranging, the order becomes important, and when you're selecting, the order is not important. Let's look at some more examples. Let's say there are 26 letters of the English alphabet. Yeah. And you want to select, arrange. You want to arrange 2 letters from 26 letters. And then you want to select 2 letters from 26 letters. So then it becomes cumbersome. As long as there were 3 letters and you had to select 2 letters from the 3, it was easy. You know, AB, AC, BC. And when you wanted to arrange them, yeah. And when you wanted to arrange 2 letters out of the 3 letters, then it was AB, BA, AC, CA, BC, CB. 6 ways. So it was easy. You could just do it on your fingertips, or you could just do it manually, write it down. But when there are 26 letters, A to Z, and you have to select or arrange 2 letters, then you require a formula. So for the arrangement, yeah, the formula is, now arrangement, you can call it permutation. Yeah. How many permutations do you have? And the formula is NPR, where N are the 26 letters and R are the number of arrangements you want to make out of the N letters given to you. So R arrangements from the N letters. All right. So then out here, the formula is N factorial upon n minus r factorial. Got it? So let's work out our 6 ways first. So if there were 3 letters and you had to arrange 2 letters, 3p2. So you have 3 factorial upon 3 minus 2, n minus r. That is 1 factorial, and that is 3 factorial itself, which is 6 ways, 3 into 2 into 1. And for selection, how many ways to select? It is combination. And for combination, we have the formula NCR. So there are n things given to you, and you are to arrange or you are to select r things out of the n. So the formula is n factorial upon n minus r factorial into r factorial. So that r factorial comes in. So again, let's take the example of 3 letters given to you, and you're selecting 2 out of them. So that'll be 3 factorial over 3 minus 2, 1 factorial, and then r factorial. So that is 2 factorial. So that will give you 3 into 2 factorial upon 2 factorial, which is 3 ways. Now let's solve the question of 26 letters. So if you have 26 letters and you are to arrange 2 letters, then how many permutations you have or how many arrangements do you have? So how many arrangements or permutations? Yeah. So then we use the formula NPR. Yeah. And you want to arrange 2. So n is 26, p, and then 2. And 26p2, if you remember the formula, it is n factorial upon n minus r factorial. That is NPR for. So therefore, this will be 26 factorial upon 26 minus 2, 24 factorial. So what you end up getting is 26 into 25 into 24 factorial upon 24 factorial. So you end up getting 26 into 25 ways of arranging 2 letters out of the 26 letters. And similarly, if you were to select 2 letters, yeah, out of the 26 letters, so how many selections or combinations are possible? So then you'll use the formula NCR, which is n factorial upon n minus r factorial into r factorial. So in our example of 26 letters, n is 26. We are to select 2 letters, so put 2 out here and then use the formula. So your r is 2, c your n is 26 upon n minus r, so 24 factorial into 2 factorial. So what you end up getting is 26 into 25 into 24 upon 24 into 2 factorial, which is 26 into 25 by 2. That's your answer. So let's just say that, Neville, I don't want to remember the formulas. I get confused. Can you show me an easier method? So yeah, there's something called the counting method. I call it the dash method. So we'll consider the same example. First, let's take ABC, 3 letters, and you are to arrange 2 letters out of the 3 letters given to you. So how many arrangements? So question is how many arrangements? Now remember, arrangements order is important. Or how many permutations, you could say, how many permutations, okay? So we use the dash method or the counting method. In the dash method, we need to focus on how many arrangements you want to make, how many 2-letter arrangements you want to say. So if it's 2-letter arrangement, you put 2 dashes, yeah? And then there are these 3 letters given to you. So the first dash can take any of the 3 letters A, B, C. 1 letter takes the position of the dash. So there are only 2 letters remaining. So 3 into 2. Second dash will have 2 options. Once 1 letter is taken up, then there are 2 letters remaining. So the second dash will have 2 options. And hence your answer is 6 ways of arranging 2 letters out of the 3 letters. And these 6 ways are nothing but AB, BA, AC, CA, BC, CB. So then what will you do if I were to select two letters out of three letters? How many selections, or you could say combinations, are possible? So if you don't want to use the formula, then use a dash. So how many two-letter arrangements? Put two dashes. Again, ask yourself, the first dash have how many options? It has three options. Multiply that. Once a letter is taken in one of the dashes, then there are only two letters remaining. So you got two options for the second dash. And because you're selecting two, blindly put 2 factorial like this. So why blindly put 2 factorial? Well, there is a reason behind that. As you could see that in selection, the order is not important. So what happens is there is a double, or you can say the arrangements are repeating, you could say twice on the whole. So to get rid of that doubling that is taking place, we divide it by 2 factorial. So we must not say dividing by 2. We must say dividing by 2 factorial. Let me explain you the reason behind that. Let's say that there are 4 letters and you were to select 3 letters, or how many 3 letter, select 3 letters. So how many 3 letter selections are there? So this, I am giving you the example as to why we must say 2 factorial and not divide by 2. The reason being is that suppose if I take 3 letter selections, suppose I take A, B and D, for example, then this A, B, D, I can write it down in 6 different ways. Look at this. You see that? Yeah. So I can also go with ABC, 6 different ways. I can also go BCD, 6. I can also go, how many arrangements can I, how many selections can I have? How many selections can I have? So out here, I've already used ABD, I've already used ABC, I've already used BCD. So I think there is ABD remaining. No, ABD is done, ABC is done, BCD is done, ACD, yeah, ACD. So I can have ACD options coming up, yeah, and 6. So out here, if this was an arrangement question, how many 3-letter arrangements I want, then you could say 6, 6, 6, 6, 24 arrangements. But this is a selection question. So in the selection, the order is not important. Hence, ABD is the same thing as ADB, same thing as BAD, same thing as BDA, same thing as DAB, same thing as DBA. All of these 6 things are the same thing in the selection. So if I were to ask you, how many 3 letters, I mean, how many ways can you select 3 letters out of the 4 letters? So select 3 letters. How many 3-letter selections are possible out of the 4? How many 3-letter selections out of 4 letters? So your answer will be, in selections, there are only 4 ways to select them, because all of these 6, in the earlier example out here, there was a duplication taking place, meaning they were repeating twice. All right. And therefore I said 2 factorial. And I said, why not divide by 2, Neville? Well, we must follow the procedure out here, or the norm out here, divide by 2 factorial. The explanation for 2 factorial is because when you were to use the dash method, that is the counting method, yeah, and put this time three dashes. If I were to select three letters out of the four letters, I'll put three dashes. The first dash has four options: A, B, C, or D. Any one can come here. Once the letter is used, it cannot be repeated. So the second dash will have three options, and the third one will have two options. So you divide it by, because you're selecting three letters, you divide it by 3 factorial. And what is 3 factorial? It is 6. So as you can see, there's a duplication, or you could say the arrangement is repeating 6 times, and therefore you're dividing it by 6. So in a way, to say 3 factorial is much better than dividing by 3, because if you were to go with this logic that, okay, Neville, why not divide by 2, because 2 factorial is 2. So in that case, when you were to select 3, you would be dividing by 3 with that logic, which would give you an incorrect answer. So therefore, you should say divide by 3 factorial, and this 3 factorial is nothing but 6. So 4 into 3 into 2 upon 6 cancels out and gives you 4 ways of selecting 3 letters out of the 4 letters. And if it was an arrangement question, if I were to ask you how many 3-letter arrangements are possible, then you get the answers 24, where in the dash method, you don't need to divide by anything. You simply ask yourself, first dash, how many options are there? 4. Okay, one letter is used up. Then how many letters are remaining? 3. Another letter is used up. How many letters are remaining out of 4? 2. And that's it. 4, 3, 2, 24 ways. So that is your solution for those people who do not want to remember the formula. But I insist that you remember the combination formula, the selection formula, because this dividing by 3 factorial, dividing by 2 factorial at times can become confusing if the question is convoluted. Anyway, let's take up a few examples. Okay, so there's this thing called um, arrangement of letters, but I'll discuss that along with my handout. So I would suggest let's go move on to the handout, yeah, so that we can discuss the questions directly now. Hang on. Okay. Right. Okay. So how many arrangements can you have if you are to arrange 3 students onto 2 chairs? Now, ideally out here, arrange 3 students on 2 chairs, you'd simply say, okay, Neville is 3p2. So I'll just write down for those people, the formula is NPR, which is n factorial upon n minus r factorial. Oh, by the way, I've got you another technique. If you don't want to do the dash method, then perhaps you can use this method, 3p2. Okay. So first we'll just go through the formula. So that's 3 factorial upon 3 minus 2, 1 factorial. So there are how many ways to arrange 3 students on 2 chairs? So that is 3 factorial ways or 6 ways. Okay. So this is the formula way. Now I'll do the dash method way, and then I'll show you another technique. All right. So a technique to just ease your calculation as far as the formula is concerned. Okay. So dash method. Imagine these are the 2 chairs, chair 1, chair 2. On the first chair, any of the 3 students can come. One of the students is seated on the chair, so there are 2 students remaining that can. So the second chair, any of the 2 students can come. Yeah, so there are 6 ways, 3 into 2, 6 ways to arrange 3 students on 2 chairs. Now, the technique I was talking to you about, the 3p2, yeah, is basically that suppose it's 3p2, then you simply start with 3, yeah, and this is 2, meaning you go down like 3p2, so you go down twice, like from 3 and 2. I know it's confusing. Let's take another example. Suppose it is 5p2. So you start with 5 and you go down twice. So 5 once and 4. So you go down. So let's say if it is 5p3. So you start with 5 and you go down 3 times. So 5, you go down. This is your going down. You starting with 1, going down twice and going down thrice, like that. 5p3. Understood? Yeah. Let's take another example. 6p4. Yeah. 6p4. What does it mean? It's to go down 4 times. 6, start with 6, go down once, go down third time, and go down the fourth time. 6, 5, 4, 3, like that. 6p4. 6, 5, 4, 3. So you begin with 6, and whatever the number out here, you could simply say count them as your dashes, if you like. So suppose it's 3p2, then this is your dashes, yeah, and then you go down 3 and 2. If it's 5p2, then put 2 dashes and start with 5 and go down till the number of dashes are there. If it's 5p3, then what you do is put 3 dashes. Because of this 3, put 3 dashes, start with 5 and go down like that. 5, 4, 3 until you've completed the dashes. And similarly, 6p4, put 4 dashes, start with 6 and go down to complete the dashes. That's it. Make sense? So that's the technique. The only thing that you need to remember, that if it's a combination question, yeah, suppose there was a question, how many ways to select uh, 4 letters out of the 6 letters, for example. Let me give you the example. Yeah. Suppose it was, yeah, how many ways to select 4 letters out of 7 letters, for example, yeah, then it would be 7C4, yeah. Now, like I said, if you see a 4, put 4 dashes, start with 7, go down to finish your, the dashes. So 7, 6, 5, 4. Now, the only thing in combination is that if you're using the dash method, the number of dashes, you divided by that many factorial, so 4 factorial. This one extra thing you'll have to remember. Or else simply remember the formula NCR is n factorial or n minus r factorial into r factorial. So in our example, 7C4 would be 7 factorial, 7 minus 4, 3 factorial into 4 factorial. They both give you the same answer. If I were to simplify this, it will be 6 into 5 into 4 factorial upon 3 factorial and 4 factorial. This goes. 3 factorial goes with 6 because 3 factorial is 6. So I got 35 as an outcome. And out here, this is 7654 upon 4 factorial. So let's work this out. So 7 into 6 into 5 into 4 upon 4 into 3 factorial. 4 and 4 goes. 3 factorial goes with 6. So you get 35 outcomes. Okay. Remember one thing, that permutations, combinations, counting, combinatorics, uh, sometimes you might get the same value. Yeah. All right. Sometimes you might get the same value, but not necessarily the question is the same. We'll look into that particular situation as a question comes up. Let's move on to the next question. Let me just check the time. Okay. We're almost in 25 minutes into the lecture, into this session, into this review. So I might just uh, do 3 more questions and then wind up. Yeah. Second question. How many arrangements can you have if you are to arrange 4 children on 4 chairs? So 4 children, 4 chairs is 4p4, yeah, which is 4 factorial upon 0 factorial. If you were to use NPR, which is n factorial upon n minus r factorial. Yeah, so in this case, n is 4 factorial and 4 n minus r is 4 minus 4, 0 factorial. And remember, 0 factorial in permutations is 1. So your answer is 4 factorial or 24 ways. And if you were to use a dash method, remember, put 4 dashes because there are 4 chairs. And the first chair, any of the 4 children can come, any one of the 4. One child sits, 3 options, so 3 chairs remaining. I mean, on the second chair, chair 1, chair 2, chair 3, chair 4. So on the second chair, any of the 3 kids can come in. Second kid sits. So now there are 2 children remaining. So third chair, any 2 options, and the fourth chair, the last child sits in. So 4 into 3 into 2 into 1, which is 24 ways to arrange 4 children on 4 chairs. So one more thing you need to remember is 4p4 means simply 4 factorial. Okay. And permutations is not the same thing as our multiplication or addition. For example, if you have 4 plus 3, we know it's 7. If 4 into 3, we know it's 12. It does not work in permutation. So meaning 4 factorial into 3 factorial is not 12 factorial. 4 factorial plus 3 factorial is not 7 factorial. It doesn't work that way. Got it? Remember that. All right, moving on to the third question. How many ways can you arrange 2 boys and 2 girls such that they are seated alternatively? So I'm just moving on to the solution out here. You can pause the video if you want to solve it on your own. Yeah. So 2 boys and 2 girls, I've got complete 4 dashes. Yeah. Now I want them to be seated alternatively, so I can have boy, girl, or I can have girl, boy, and that's about it. There's just 2 ways to arrange them. If I start with boy, then there are 2 options I have. Yeah. This dash for the boy, any of the 2 boys can come here. One boy takes this dash, so there's only 1 boy remaining, so 2 into 1. So that 2 into 1, I can call it 2 factorial. And same thing for the girls. The first dash, I have 2 girls, so 2 options out here for this dash. One girl takes this dash, so for the second dash for the girls, there's only 1 girl remaining. So 2 into 1, 2 into 1, 2 factorial into 2 factorial. Or means plus. And same thing out here, 2, 2, 1, 1. 2 factorial into 2 factorial. So my answer is 8. 2 twos are 4, 2 twos are 4. 8 ways of arranging 2 boys and 2 girls such that they are seated alternatively. There's another way I can solve this question. So suppose altogether there are 4 people or 4 children, right? So there are 4 options in the first dash. So depending if it's a girl or a boy, let's say it's a girl, then I know instinctively that the next one is going to be a boy, then third is dash for the girl, and then the fourth one is for the boy. So out here, suppose if it's a girl, yeah, then the next one out here will have only one option because one girl is already seated out here. And there are 2 boys, because a girl is seated out here, there are 2 boys remaining. So the second dash, 2 options I have. And for the last one, there's only one option because one of the boys are seated out here. So there are 8 ways directly. I can solve it this way. But this is slightly difficult to understand. Yeah. So remember, permutations, combinations, counting, these are very difficult topics. I have taken very easy examples for your understanding. Yeah. Now, I think I will, let me see what's my next question. How many ways can you arrange 4 boys and 3 girls such that they are seated alternatively? Okay, so what I'm going to do is I'm going to continue with question number 4 in my next video. So I'm going to stop this live session and continue with this maybe in this week before Sunday. Yeah, I'll make one more video on permutations. Overall, there are about 19 questions, so it might go up to 3 videos in this one. So next time I'll see you. If you, I don't know if I will take live. I'll probably record it and put it on. But I would love to take it live, so I'll try to take it live. Yeah. Thank you.